Alright, today we're going to do a video of a part we're doing for the University of Central Florida. They're making some kind of robot, or not robot, some kind of submarine. I know it can't be a cheap submarine because it's got one sensor alone that costs 30 grand in it, so they've got some CNC machines that apparently nobody can run them. So they brought it over to us, and me and Jordan's been messing with it. So when it first dropped in, you seen it stop, I don't know, 100 thousandths above the part, and it started to do its helix in. I want to say I got a program for 3-degree helix, but I could be wrong. Somewhere around there though. But it helix into the part. That was a slower portion, and then you can see that it really, once it gets down to the depth that it's going, it starts hauling ass. So right there we're running at 100 inches a minute, probably 7,500 RPM. Spindle max is out at 8,100. So I try to program it a little bit under its max. That way you got room to override it if you need to. So when we're first first getting into that pocket, it really builds up chips real bad down the far side. And then I got one of the, you see it's got 3 coolant spouts on it. And I got one of them coolant spouts shooting in front of the tool. So, from there on out, it pretty much pushes the chips. But when it's first doing that hogging, it builds up. So, in the program, you're going to want to put a stop in there to go in and clean the chips out. This is just a test run. That's why it ramps down. Again, I always do that 5% once it gets close. So when I'm doing my ramping in both of these videos, you'll see it's going in real slow, and that's because I got it turned down. So we're just proofing out the program. And this thing's been a nightmare for Jordan. The other 2 parts that he was working on, just something always going wrong. 99% of it, none of his fault. Just piss poor idea. You can see what it's doing there is it's roughing the edge in real quick. Now there's 3 steps in this, so you'll see it does that fast machining. The first step, it bores the entire thing to the widest step, which is at the bottom. Then it comes up and it machines the second widest step. And then it steps up and does the 3rd widest step. And then that is nothing more than a contour. So we programmed an adaptive clearing. The first operation is just an adaptive clearing, and the adaptive clearing goes in and roughs it. It's running at, like I said, 100 inches a minute, 7,500 RPM, something like that. Using HSM advisor to calculate it, and it ramps down, just machines it out. Then you've got 3 contour operations, 1 for each one of those steps. And sometimes you can get away with 1 contour operation and pick all over. I just had no problem typically when I try to jam everything into one thing, so I'll just make 3 different operations if that just makes it go smooth. So then what you can't see here is that fixture plate there sitting right next to the other one. Now that other one, we've got a fixture plate. It's got the set screws in it. And what we do is we raise up 3 of those set screws. You can get away with 2 of them, because all this stock's coming out of the same piece of round. So you raise up 2 or 3 of those set screws, and then you can just jam your stock in, boom, 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 because that creates a stop for it, and then we clamp it down, because it's going to cradle itself into the, actually we use 2 set screws, not 3. It cradles itself into the, I use 3 on square stock. It cradles itself into that little nest, and you don't have to reset your datum for each part. And then the fixture that it's on now was a fixture that I made earlier in the week just for this. And it's a 2-sided fixture. One side's machined to 7 inches, and the other side is machined to 6.99. Yeah, it was only 10 thousandths under. And that locates the 3 separate parts on that one fixture. And I made the fixture so it's got 8 holes in it it's got 4 holes that fit the T-slots on the table. Then it's got 4 holes that fit a fixture plate. And then it's just got a bunch of tapped holes in it for our clamping. And I'll show a picture. I'll show a picture at the end of the fixture plate. Talk about it a little bit. And when I do the programming video, I'll just put the fixture plate in there with this, because these are really pretty basic and pretty fast videos for something like this. It's just a circle, really. So essentially we do the inside on one piece, and then that inside locates on this piece here, and we clamp it from the top. And again, it's got 2 steps, so it comes in and it machines the widest part, then it steps up, machines the next widest part, then the tool goes up and it comes back in for the contour operation, where we because the adaptive clearing is a roughing operation, so it doesn't leave a very smooth finish usually. So the contour operation comes in and does a cleanup on all those edges. We leave 20 thousandths for that operation. You have to look at it all clamped down.